Okay, so moving on with the logic and compare instruction. So we first start with the AND logic gate. So for the AND, we know for a fact that AND could be only one ang iyahang output if and only if the two inputs are 1. Otherwise, ang atong result would be 0. So that is the rule of our AND. So for the AND register, the source is RD and the destination is RD and the source is RR. And the register can go from 0 up to 31 and the R or the source is from 0 to 31 also. And the AND instruction performs a logical AND on the two operands and place the result in the left-hand operand, meaning the destination. This is our left-hand operand. And there's also AND I, meaning the constant, ang source. So the destination is from 16 to 31 and the K is from 0 to 255 instruction, in which the right-hand operand can be a constant value. So magsugod ang atong destination register is from 16 to 31 for AND I. And the AND instruction will affect the 0 flag, S, and N flag. It is often used to mask the set to 0 certain bits of an operand para ma-zero ang certain bits or certain nibbles. So let's have an example. We have 0x35 loaded in register 20 here, and we have a logic AND I R20 of a value 0f loaded ANDed with register 20. So we have 35h ANDed with 0f. So the result would be 05. How come that we have that value? So putting that 35 hex to binary and 0fh to binary, we can see that it follows the rule nga it masks certain bits of the operands. So as you can see, the first nibble of this digit is having a value of 0, and the next nibble is 0, 1, 0, 1. With that, R0 is Z is equal to 0 and N is equal to 0. So for the logical OR function, we have this value. We know for a fact, as long as that if ever we have the inputs either 1 or 0, basta na 1, then our output would be 1. Unless if our both inputs are 0, then we have an output of 0. And OR also could have the register's value from if the destination is coming from the value of 0 to 31 and the source 0 to 31 also. The OR instruction performs a logical OR on the two operands and place the result in the left-hand operand. Pareho raghapon ganina sa AND. So dito ibutang ang destination ang result. So there is also OR I, ganina na AND I, for a constant value. The OR instruction will affect the 0, S, and N flags, same with AND I. It can be used to certain bits of an operand to 1. So having this example, we have 04 loaded in register 20 and 0x30 loaded in ORing it into register 20. So we have 04 and 34h ORing it together. So representing it into its binary format, we have 04h equal to 00000100 and 30h 00110000. So as you can see, kung ang AND gimas niya ang certain gimas niya by having 0 na value, kabaliktaran po ang OR. Ang iyaha, it can set the certain bits to an operand to 1. So, ang nahitabo here, pag naay 1 dito, i-carry niya ang 1. So, naa direct 0, 1, 0, 0. So, that is the difference between AND and OR in the operation for a register. So, okay, going back to the sample for the exclusive OR, we have here an example of to read and test the port B to see whether it has a value of 45H, and if it does, we'll send 99H hex to port C, otherwise it is cleared. So first, we have to set the value of DDRC as an output. So to do that, we need to have a value of the R20 equal to 1 or set. So we have 0xFF loaded to R20. This FF has an equivalent of 8 to 1. So meaning all the bits in the register 20 are having a value of 1. And also, we have the port B as an input, because port C is an output and port B is an input. So to set the port B as an input, we know that DDRX must be equal to 0. And to do that, we need to have a value of 0 loaded to R20. So mahimo na 0. And this 0 here shall be put in DDRB. So nahimo ng 0 ang DDRB. And we already have set our port C as an output and port B as an input. Then we need to clear out first our port C para ma-clear siya. So we have R20 getting an output in port C. So since this R20 is still 0 in here, and then we have to load 0x45 in R21. So this R21 will be our basis for comparison if our input in the port B is 45 also. If it is 45H, then we'll send 99H to port C. So in here we have a loop. Ang pin B, gibasa nato, put it in R20, and then exclusive OR them together. So we have here 0x45, i-compare nato sa value sa R20. If it has a value of, if in case we have a register 20 equal to 0x45, our output would be 0. Since we know for a fact, if ever nga exclusive OR nga atong gamiton, since here we use exclusive OR, having two register with having the same inputs will have an output of 0. Otherwise, kung different ang ilang inputs, will have a value of 1. So since let's assume na ang R20 or register 20 is 0x45 also, then we'll have an output of 0. Therefore, kung ang atong output is 0, then our Z na flag is equal to 1. And then, since Z is equal to 1, we'll have here BR and E here. So, mo loop siya sa kini na function. So, if ever na has a value other than 45, mobalik siya. But if Z is equal to 1, mo proceed siya kini sa nga value. Ang atong 0x99 i-load nato sa R20, and this R20 now have a value of 0x99 and will have an output sa port C as 99H as directed sa kini nga instruction nga kung ang atong ang atong value sa atong input B or port B is 45, unya nas pareho sila sa 45H nga value, then maghatag ta og output nga 99H. Otherwise, we'll have a clear na value. So, mao siya ang gamit sa atong exclusive OR. Another use of application of exclusive OR is to toggle the bits of an operand. So, for example, we have the register 20 having a value of 0xFF, meaning all the bits in 0xFF is equal to 1. Using exclusive OR, we'll have a value of R0 opposite to 0xFF.